say it.
Today's the 10th.
Yeah, that's what I meant. Week of the 9th. Week of the 9th, day of the 10th, all day. Today is Tuesday. Today is a moron day. When I say moron, too soon. Today is a moron day, meaning not that you are morons, but we're doing more on the last lesson. And by the last lesson, I mean the last lesson you learned in 5th grade. Okay? We're talking about polygons today. You know them, you love them. It's all review. We have no notes is what I'm trying to say. No notes today, just a little bit of stuff to write down. Nothing really that's going to blow your mind, okay? But before we get into that, here's what we're going to do. Our warm-up today is to construct and measure some angles. So you're going to use a protractor, right? You know, the ones you pick up at Farm and Fleet, the professional kind. Protractors. And then we also have the compass. And you'd think the compass would be the round one, wouldn't you, Rosie? You would think the compass would be the round one. But it ain't. This is a nice compass because it's metal and it has this nice point. And it has this adjustable thing. We've talked about this, right? I wish everybody had one of these. You don't. So what you need to do is before you start bending it and pulling it apart, adjust the nut, okay? Loosen it up. And then when you find the setting you like, then tighten that nut, okay? Then that way it won't like jump on you and move around. That's good advice. All right. Yeah, probably. But you know what? We try to keep it contained. All right. Again, not moron, but moron. So here's what we're going to do first. This is our warm-up. Okay, what we're going to do is I'm going to run through it with you first. We're going to do construction together, and then I'm going to turn on some music and you're going to try it out on your own. Okay, so pay lots of attention the first time we do it. That way you get the instructions, and then you can try it on your own later, okay? And then when you need help, you can ask for me to show you the way, which is also the song of the day by a man named Thundercat. All right, here we go. First thing you're going to do. Take out your writing utensil of choice that does not bleed, can't be blood, and draw yourself an angle. What is an angle? An angle is two rays meeting. And where do they meet? At the end point. On your warm-up thing. If you need more room, do it on the back. I'd save the back for when you do it on your own, though.
Is that what the hole's for? Drawing circle?
It can be, but it also helps you line up the end point exactly, right? That's what that thing's for. We'll talk about how to use this thing. Again, your angle can be any angle, including a straight angle. If you're really lazy, right? Just one line. We're going to bisect this angle. What does it mean to bisect?
Put a ray in between.
Put a ray in between it, which cuts it in half, right? Lots of rays can go in between. Hi, Ray. But only one ray will bisect this, cut it in half, right? So we're going to make an angle bisector, a ray that cuts something in half. So here's our angle. The next thing you're going to do is take out your compass. Okay, that's not the round one. And what you're going to do is set up your compass so that when you place the pointy part on the end point, that the compass setting is less than the length of your rays. So see how this is smaller than my ray? That's good. That's good.
There.
Ray's a pretty tall guy. I think he's like at least 6 foot. All right, so here we go. Now we're going to draw an arc, and that arc should hit both rays. And if you think about it, that arc is just a piece of a circle, right? With the center here. So when we set our setting for our compass, really what we're doing is creating a radius, aren't we? Yeah, we're making a circle. We're just not drawing the whole thing because we don't need the whole thing. So that length right there is by definition the same length as this right here. Well, it should be. Put 2 dots where the arc intersects your rays. Okay?
Oh, is that supposed to have a bolt in it?
Yeah, it is. You just do your best, okay? All right. Let's name this angle. What do you want to call it? Angle what? What'd you say? Bertha? Okay, but like I need 3 letters. Is there a 3-letter name you want to name it? Gap? That's not someone's name.
Why is that?
It's a company.
That's I need 3 letters. Pam. Angle Pam.
Oh, I thought she said ham too.
All right. So Pam, what do we know about angle Pam?
Did you get that from the office?
No.
Could have been anybody. I went to school with a girl named Pam. Hi Pam. So anyway, what do we know about angle Pam?
Oh, it's an angle. It's a cute.
Come on, we just named it. What does it tell us about the points?
It goes P, A.
Exactly, P, A, M. So A has to be the vertex. P can be either on top or on bottom. Again, P and M aren't particular about whether they're top or bottom. They're cool with that, okay? So, I don't know what you're talking about. All right, so here we are with the angle. Okay, we've named it Pam. I chose to put P on top. You could have chose differently. Again, it's, you know, live your life. You do you. What we're going to do now is take your compass out again. I know, no. And what we're going to do is pick a setting. Pick a small setting, okay? And make sure that you tighten it once you get that setting, because we're going to use that setting twice, okay?
Like a small?
Yeah.
Like that?
Fairly small. It needs to be able to reach about halfway across the angle. See how this angle right here, I can draw an arc that goes through the middle of it? Right, we're trying to bisect this thing. So what I want to do is make sure that my arc goes more than halfway across between these 2 points. Okay, so check it out. Check it out. Here's a better way of saying it. See how that's more than halfway between P and M?
Yes.
Okay, set your arc to something like that. Okay? Then keep that setting. Okay, so don't lose it, and do the same thing at M. Okay, make sure that those arcs intersect. That's why we made them more than halfway.
Oh, I understand what you're saying.
All right, so again, for those of you following along at home, we pick a setting on P, a setting that is more than halfway between P and M. Then we draw an arc. We keep that setting, we start on M, and we draw another arc. Where those arcs intersect is going to be a point. Label that point, what do you want to call it?
W.
W.
Y and Z.
Can you go? Thank you.
Is the hardest part following the directions or actually using the compass?
Yes.
That's what I want to hear.
I didn't do it right.
I think it's a mixture of
This thing does not cooperate.
Yeah, I'm sorry. I want a payday's on Friday. Maybe I'll buy you all a set of these.
Please don't.
Are they expensive?
I feel like it's important. Bills are optional. I just wanna.
He's gonna use.
Yeah, why spend money on kids? They're just too dumb. They can't learn,
There's
right?
gonna die one day anyway. We're on a diet.
Definition of stupid.
Literally, that's a Supreme Court ruling. They're like, yeah, kids are too dumb. Money doesn't matter.
Money does.
It really does. All right,
It
so
does buy you happiness.
connect AW. That's might be true, but happiness is not joy. All right, here we are. A to W. That's going to be a ray, and that green ray is called AW. Okay? AW. Right? That green ray is what we call an angle bisector. So we're going to write that. Ray AW. We're going to let. Yeah, because we constructed it, right? So let ray AW bisect angle. What angle did we bisect? I'm color coding here. What angle did we bisect here?
Yeah, Pam.
Angle Pam. Right down the middle. So we said let this, right? So we could draw it out and let it be, right? We created this. We constructed it. Let there be light. We said let there be an angle bisector. Let it be called AW and have it bisect angle PAM, right? We let that happen, right? We created it. So another way, instead of doing that, is to write it. Let AW, the ray, bisect PAM. Let it be, right? We don't need to construct this because we know we can do it for any angle, right? We just proved any single angle we do in here without, calling it a certain degree, right? We didn't measure this thing. We can bisect it, right? So let there be this.
Rosie, we are.
Now, what do we do with this? Well, if this is true, if that's true, then therefore we know what? What do we know? This thing's a bisector, so what does that imply? It's silly that I'm asking this because it's so simple. It's kind of hard for you to be like, well, that's what he wants, right? What I'm asking is, what does that tell us about these two angles right here? They're congruent. So therefore, angle, what's the top angle called?
P.
PAW, paw, not P. We need at least 3 letters here. We can't call it angle A, right? Because we have multiple angle A's. PAW is congruent. Remember, we're talking about figures here. They're not equal. Angle PAW is congruent to angle WAM. Now, I'm going to call it MAW instead, and I'll show you why.
Because my dog's gonna haul.
Pa and Ma. It's like you planned it. Maybe I did. So check it out. A and W are in the same spot for both of them, which is nice. We can easily tell those should be congruent because they're the same in almost every way, right? If we write it WAM, less things are in common. It's just good to line things up if you can, right? So I did Pa and Ma. Aw. How did he do that, right? It's like we're doing a thing. You don't even know it's a magic trick. And then I'm like, is this your card? And you're like, oh, my God, that is my license, right? How did you have that? It's like I've been doing it this whole time. Pa and Ma. I know you said Pam.
Because he's driving your mind.
But then he said W.
I did.
Now the question is, did I plan that, and how did I create that? Go back and watch the video. All right, so here we go. I love what I do. All right, so we know that to be true. Also, if those two are congruent, we also know that the measure of angle PAW is equal to the measure, ladies and gentlemen, MAW. Right? I mean, it kind of goes without saying, but let's say it. Right? That's what we can conclude. If this is true, that's true. We let it be, and that's what happened. It's the result of our creation. That's right. So, how do we construct this? Eyes up here, so you're not fiddling with your compasses. Okay, this is what you need to know to be able to do this on your own. And I'm going to show you this, and then I'm going to do one more construction that we've already done before, and I'm asking you to do both of them. So I'm going to hit it a third time, just in case you don't get it. Okay. So here we go. First time, we put our compass on A. We extended it out. As long as it was smaller than our ray, it was fine, right? So we extended it out. We drew an arc. It hit our rays twice, once each. Then we went to P. We made sure to extend this out to about halfway, or a little more than halfway between P and M. We drew an arc, did the same thing at M, drew another arc where they intersected was W. There's our bisector, okay?
Wow.
I know, wow. It's like right now. And that's how we did it. If you're feeling at 50%, that's great, because I'm going to hit it one more time. We're going to get that last 50%, okay? But we're going to take a break for a second. Wow, Mom, right? Here we are. Next thing, we're going to bisect a segment. You remember that one? Draw a segment. This is the first construction we ever made. So it should feel familiar.
Wait, we're gonna draw that right now.
Draw a segment right now. We're going to call it AB.
On what paper?
Do it on the back.
Do it in the back. Come on, think outside the box here. What have I taught you?
If I don't like to be outside of the box.
Welcome to geometry class. You're not going to have a good time. Okay? All right, AB, we're going to bisect it. So we're going to cut it in half. Here's what you do. After you draw your segment AB, open up your compass to a setting that's more than halfway between A and B. So if I open it up like this, yeah, that's more than halfway, right? Maybe you remember this.
We did this before.
We did. We've been here before. Yes, Samwise. All right. Draw an arc, which is really a circle. We're going to draw a circle centered on A and draw a congruent circle centered on B. They have the same radius, right? We're keeping the same setting. And where those circles intersect, they should intersect twice, is going to produce 2 points. What's going to happen at those 2 points?
Does Haley not know how to use a compass?
Yes, she does.
Wait, did you say
Thanks,
move it over a bit?
Make sure it's more than halfway between A and B, right?
Yeah.
And then keep that setting when you do it again at B. Yeah, it's all about keeping the setting. We want 2 congruent circles intersecting, because where they intersect will form a segment. Let's call it CD.
So we already did
This is what I got.
We did.
Not there yet.
And it should hit AB and bisect it. Bisect means cut in half. For those of you that are lost, because you're messing with your compass, here's what I did. I opened it up to more than halfway. I drew an arc at A, and then I went and did the same thing at B using the same setting.
Turn the paper.
Where those guys intersect forms a segment, and that segment is a perpendicular bisector. So not only does it hit AB and cut it in half, but it hits it at 90 degrees, right? Perpendicular. Like, where did it go? Oh, man, I had the joke for the first couple hours. Where's my per pen? Oh, bummer. All right, well, imagine a purple pen. That was the hint. I used to do the whole thing in purple. It's okay. You can watch first hour's video. I know you will. Like and subscribe. All right, so this is a perpendicular bisector. Let's write it. Easy. Let AB. Now let's let DC. That's what we created. Let DC, sorry, words are hard.
It's okay.
Perpendicular bisect. That's the symbol for perpendicular. Perpendicular bisect. What did it perpendicular bisect? What segment did it perpendicular bisect? AB. Now, fun fact. Not only did AB get perpendicularly bisected, but DC is as well. DC is broken up into 2 equal pieces and it hits at 90. Now notice DE is not the same as AE, right? Those guys are not the pair. Those are the pair, okay? And those are the pair. So in order to save time and space, I'm going to do an arrow both ways that says, look, not only is DC perpendicular bisecting AB, Not only is DC perpendicular bisecting AB, but AB is perpendicular bisecting DC. That's shorthand for it goes both ways, right? Is that an official way to write it? No, I'm just being really short here, okay? Now, what does that tell us? Therefore, segment AB, segment AE is what? Segment AE is what? Starts with a C. Congruent. It's an equal sign with a tilde. It's like Spanish equal, right? Equals segment BE. And again, I'm trying to line up the E's here, so I'm going to write B instead of EB. B as in boy first, then E last. This also tells us that segment DE is congruent to CE. I like how you said that. Not EC, but CE. Just bonus points for making a match, right? Lastly, we know that angle DEB, let's do Deb, right?
Debbie's credit.
The measure of Deb
Awesome. She's like,
is 90,
She is.
right? Debbie's a G, guys. She's great. Measure of angle DEB is 90, right? And you can say that equals measure of angle DEA, which equals the measure of angle CEA, which equals the measure of angle, what's the last angle? CEB? Is that what I want? Yeah. Do you see what I'm saying here?
That's tough.
Right? It's just saying that all four angles are equal and they all equal 90. All four angles are equal and they all equal 90. Right? This one equals 90 and they all equal each other. That's all the information I got from that, right? Let DC bisect AB. Therefore, I know that AE and BE are equal. I know DE and CE are equal, congruent. And I know that all the angles are equal and they equal 90 because it's a perpendicular bisector. You feel me? No. Okay, well, fair enough. Here's what you're going to do. On your own for your warm-up and play some music, okay? You're going to bisect a segment on your own.
I'm gonna do it by myself.
I know. On the back, you got room.
Not that hard.
Okay? You're going to bisect an angle at a segment on your own? How do we bisect the segment? Look at here. We drew the segment. We went more than halfway, drew an arc. Went more than halfway, same setting, drew an arc.
Does it matter
Done.
when we-
You also need to do,
Oh, do both.
porque no los dos. We need to also bisect an angle. Draw yourself an angle.
Okay.
Set a setting that's smaller than your ray. Draw an arc so it hits both of them. Go to your first dot, draw an arc. Go to your second dot, draw an arc. Make sure they intersect. When they do, you've got your perpendicular bisector. Try it on your own. If you get confused, I will show you the way. Okay? Just raise your hand and ask. I'll be walking around. The song of the day is "Show You the Way." Do you know the way? Right? Show you the way. By Thundercat. Thundercat is a very large black man that is amazing at bass. Okay? This guy is huge. He's intimidating, but he plays the bass in such a way, right, that just makes you want to feel like everything's fine, right? He's got these sick dreadlocks. I saw him in concert that used to be rainbow colored. Like, this man is just like a vision to see. You have to see him, okay? You should go see him live. If you get a chance to see him live, go see him with Flying Lotus, because that stuff will blow your mind, okay? Blow your mind. You don't need it, okay? The show's in 3D. Like, you get 3D glasses for it. It's an experience, okay? He's the greatest bass player alive, period, and he's probably the greatest bass player to have ever lived. The guy's name is Thundercat. Along with him on the song, okay, from his album Drunk, back in 2016, has amazing album art. The song is "Show You the Way." Kenny Loggins, the white guy you think of when you think soul music, that's Kenny Loggins. He's the guy that did Footloose's soundtrack, okay? He's on this track along with a guy that you probably don't know as well.
Kenny Loggins is We Are the World.
He was one of the We Are the World people, right? Also on this is Michael McDonald, who you were probably conceived to, let's be honest. All right, here we go. Show you the way. Most of the sounds you're hearing right now are all his bass. He has a 12-string bass. Like, he just does everything. Drums are different, the synth is different, but everything else is all different. This song won't blow your mind. Flying Lotus and stuff will with Thundercat, but this is just like everything's good. So, Michael McDonald. Michael McDonald. You've heard this song before, guaranteed. Not this song, but this guy's voice. Guaranteed. You might not have been like aware of it, but you were there. I'll Show You the Way by Thundercat from the album Drunk. Came out in 2017, 23 songs. That's track number 9 featuring Michael McDonald and the Kenny Loggins. I know. All right, so now it's time for our moron. What are we going to do? Well, we said we construct and measure angles. We did that. We didn't measure them, I guess. Let me show you how to measure them. Can I have my souvenir back? Yeah.
You can have this if you want.
All right, check it out. If you want to measure, this is how you do it. Okay, let's see how good my angle is. Almost every class today, I've hit like an exact angle measure. It's been really nice. So what you do is you take the circle part, the center, and you put it on your endpoint, right? You line up this little bit right here with one of the rays. So I'm going to line it up with this one. Oh, man, we got like right between 40 and 50, so 45 almost exactly. Yeah. Dang, I'm good. First hour, I hit 15. No, I hit 25 exactly. Second hour, I hit 50 exactly. Okay? 45 exactly right there. Now, there are two numbers here, right? You see a 40 and a 140? Well, the 40 is from this side, right, if we measure from here. If we were to measure from here, that would be 140, or in my case, it would be 135, right? So there's two different ways to look at it. You're dealing with an acute angle, you better have an acute angle, right? So don't think, oh, it's 140, right? Because that's what it says up top. No, this is a 40-degree angle. It's an acute angle, okay? It's just giving you the supplementary to that. Questions on how to use a protractor? I know that's the fast and quick of it, but like that's all we got time for, right? Moving on, more on. Today we're going to talk about regular polygons, which begs the question, what does it mean to be regular?
Skinny. Skinny.
You're all individual, you know, and unique.
A square.
Regular.
All of you. We're going to talk about it, okay? Get some fiber in your diet. We're going to talk about concave and convex, and we're going to talk about perimeter and distance and how they relate to each other. So I'm going to zoom out. And we're going to get into this by going with a worky sheetie. No notes today because it's a moron day, right? So here it is. Here's your worky sheetie. I stole that from a teacher at Sandwich High School. His name was Dr. Blackwell. No one called him doctor, and it made him very mad. He had very pudgy hands. He played the bass, speaking of Thundercat, and when he'd like high-five you in the hallway, because he was like this old guy. Anyway, you go to high-five Dr. Blackwell, and your hand would sink in like 5 inches, because his hands were just like so like chubby.
Oh yeah.
That's
It's 5
And he'd always say things
inches.
like, as we carry on, right? That was Dr. Blackwell. Shout out to Dr. Blackwell. He played bass. Good. Write the name of each polygon. So that begs the question, what is a polygon? Well, let me tell you what a polygon isn't.
What's up?
Pay attention.
Polygon.
Hands, arms, and legs inside the right at all times until we've come to a complete stop, okay? It's going to be fast. Here we go. Polygon, what isn't it? That's not a polygon. Here's why. Polygons have to connect, their sides have to connect at endpoints only. See how they connect here? That's not an endpoint. That's an endpoint. That's an endpoint. That's not an endpoint, so not allowed, okay? Even if I did this to connect those guys, still not a polygon because it connects somewhere that isn't an endpoint, right? So not only can it be, you know, it has to be closed, right? But the endpoints have to be connected, which is another way of saying these guys have to be closed and that they can't be connected elsewhere, okay? What else is not a polygon? The circle, not a polygon. It has no sides, okay? Circle's perfect, we love it, but it's just not it, okay? That's right, she round. So here we go. Tell whether each polygon is convex or concave. Well, there's two big types of polygons. They're divided into 2 bits, okay? Convex, concave. Concave polygons cave in. So this is what this looks like, okay? Here's an example of a concave polygon. See how it caves in?
Yeah.
All right, cool. That's a very loosey-goosey term. The more mathematical term is that if you look at the internal angles, internal means what? Inside, right? Like inside voices, internal voices, which are the voices I hear all the time, but I mostly ignore them, right? So if you look at the internal angles, okay? No, we don't. Dan, no, they're fine. Don't, you don't have to hurt them. All right. So if you look at the internal angles, okay? One of the internal angles at least has to be a reflex angle. What's a reflex angle? Hyperextension, right?
Yeah.
Over 180. See how that's bigger than 180? If at least one of the internal angles is more than 180, then the thing is concave. So that's a formal definition, right? That's something we can check. Another way to think about it, visually, okay, is if you were to extend these lines out. See these segments, if I were to extend them? See how that one goes inside when I extend it? That means it's concave. Okay, so for like this one right here, is it concave or convex?
Convex.
Convex, because none of these lines extend inward, right? Also, we have no angles that are over 180, right? That's more than 90, but it's not over 180. 180 would be a straight line, right?
Yeah.
So that's less than 180. Same thing here, less than 180. That's even less than 90. This is slightly more than 90, but less than 180. This is slightly more than 90, but less than 180. None of those are reflex angles. None of those are, snapping your elbow too far, right? So we have two things, concave and convex. Convex is not concave. That's kind of how we define that, okay?
I get it.
An example of something that's convex would be like this. A pentagon, like that. Concave would be really painful to put in your eye as a contact, wouldn't it? Convex would be a nice contact. Okay, all the sides push outwards, not inward. Then we break it down into names of the polygons. Now, the names are based on the sides, okay? We're going to talk about some really common names in here. There are infinitely many names out there, just like you guys have infinitely many names, right? Anybody can be named anything. Now, there's some that are more popular than the others, right? Like, for instance, like Becky, Jenny, Steve, John. So we're going to introduce you to the Beckys of the Polygon world, okay? Those are the ones you need to know. Okay, so here we go. Number one, you've probably heard of it, okay? It's a pretty common name, triangle. Triangles have 3 angles, which is why we call it triangle. Turns out, the only way to take 3 line segments and connect them is to make a triangle. There are no other versions of triangles, or 3-sided polygons, right? So we just call all of them triangles. They're there's like one thing here. And you'll know what I mean when I talk about the next one. Now, 4-sided figures, there's lots of different ones, right? We have pentagon. We have squares. We got rectangles. We got rhombus is mathematical, right? Okay. Trapezoid, right? Parallelogram. Kite. There's lots of them. So we need a catch-all term. So we call it a quadrilateral. Quad meaning 4, like 4-wheeler. Lateral meaning side. That's the Latin word for side. So like the lateral portion of somebody would be their side, right? When you throw a lateral in football, it's not a forward pass, it's a side pass. So lateral means side, quad means 4. So quadrilateral is any polygon with 4 sides, okay? Next is pentagon. Now a pentagon, okay, is Satan's symbol, apparently. I'm not sure why, because it's the number 5, and shouldn't the number 6 be Satan's symbol? And that would make more sense, because they call it a hexagon, and aren't hexes really more satanic? I don't know. I don't make the rules, I just follow the cult that, instills them. All right, so 6 for hexagon. What? Next thing, okay? Septagon. Now, we're not going to call it that, because no one does, and I'm not even sure if that's it. I just made that up. But it sounded real, didn't it? Okay? We're going to call it a sevenagon. So, sevengon. That's what we call things if we don't know what it is. Now, are you going to call a hexagon a sixagon? No, you're not, okay? You're going to call it by its real name, Becky, okay? Sevengon is just somebody else, okay? We don't know that one. We don't care about it, okay? That's not a Becky. You need to know the Beckys. All right, 8. We don't call it 8gon. We love this one. It's the octagon, the stop sign, yay! Or if you're a UFC fan, right? The thing they fight in. So that's an octagon. 9gon is fun to say, 9gon. But it doesn't have an official name, at least not in here. 10gon has a name. A decagon. And you know why it's called decagon, right? Because dec means 10, just like December is the 10th month. Tecagon is 10. Now, if we take that same logic, 11 is an 11gon. We don't need to know that one. But we do need to know the next one, which is a dodecagon. Do meaning 2, dec again, like December, means 10. Dodec.
Sounds like Pokemon.
Agon. Yeah, it does, kind of, right? Collect them all. There's 12. You don't need to know all 12, right? Because we don't have one for 1. We call that a segment. We don't have one for 2. We call that not a polygon, right? 3 is triangle. You need to know 4, need to know 5, need to know 6. Skip 7, need to know 8. Skip 9, take 10. Skip 11, take 12. Okay? Those are the ones you need to know. Now, question, which one is this? Pentagon, because it has 5 sides. So that one's a pentagon. Well done.
So you have to put
Satan's symbol.
convex pentagon.
It is a convex pentagon. And it says mark congruent segments. Yeah, we don't need to write all of them out and then circle
No,
one.
obviously.
Yeah. Mark congruent segments. Congruent means that they are the same length, because segments only have length, right?
I can't read the stuff
In the blue? Because it's blue?
Are those like congruent segments? Right?
Concave?
Yeah.
Okay, gotcha. No, it's okay. It's fine. Thank you for asking. All right, so now we need to figure out which segments are congruent here. So we need to measure them. How do we measure stuff? Well, we could pull out a ruler, but we are men of science. We have the technology. We know distance formula, right? Now, distance formula sounds gross. That's a lot of points to plug in. But what is the same as distance formula, but easier?
Half, whatever.
Pythag. So if we make this into a right triangle with that as the hypotenuse, can't we easily figure out how big the hypotenuse is? That side's 3, that side's 4. What's 3 squared?
12.
9! What's 4 squared?
16!
A fun game to play outside. 9 plus 16, all rooted. What's 9 and 16 make? The only thing funnier than 24, 25. What's the root of 25? 5. So that side is 5. Now, if you don't have 3, 4, 5 memorized as a special right triangle, you should. It's a Pythagorean triple. It's nice numbers that produce nice numbers when you put them in the Pythagorean theorem. 3 and 4 make 5. So when you see that, 3 and 4 for legs, you know 5 has to be the hypotenuse. I wonder where we could use that next. Let's measure EB. Randomly chosen.
No, not random.
That's a 4 and a 3, isn't it? So what's ED going to be?
The same thing.
It's going to be 5, isn't it? So if they're the same thing, they're congruent, right? So put a tick mark there and there. Ta-da!
You did.
Or we could have plugged in those points to the Pythagorean or the distance formula,
No.
right? How about no? How about we don't and say we did, right? All right, so here we are. Now, let's find other ones that are congruent. Spoilers, none of them are. But we need to find the sides anyway so we can add up the perimeter, right? So let's keep going. As we carry on, Dr. Blackwell, 1, 2, 3, 4, 5, 6 is what this is, vertically between D and C. Horizontally between D and C is 1, 2, 3, 4, 5, 6, 7, 8. Oh, man, that's not a 3, 4, 5, is it? Yeah, it is. 3 times 2 is 6, 4 times 2 is 8. So instead of 5, we're going to have what? 10. Very good. Over here, this is not a nice one. I don't kid you. Because this right here is 4, and that right there is 6. And 4, 6, something is not a Pythagorean triple. What's 4 squared?
16.
A fun game to play outside. What's 6 squared? 36 plus 16, 52. So we have root 52, which sounds like a fun place to drive. But it's not a nice root, is it?
No, it's not.
4 squared is 16?
Yeah, why'd you do that though?
Because 4 squared is what we get here. 6 squared is what we get here, right? We add them up and then root them. That's root 52. That's Pythag. Good question. The perimeter then is going to be 5 plus 5 plus 10 plus 4, because that's what AE is, plus root 52. Add them all up and leave the 52. We get 24 plus root 52. That's the perimeter. Ladies and gentlemen, if you want to know how to do the rest of it, look at one of the videos online. We didn't get to all of it, but all of it is doable if you know how to do this stuff, okay? The last page has some self-development.
So you repeat the
I do. Okay, go to the end and fast forward to the last page. It explains this stuff, but honestly, you don't need an explanation. You can do it without.
Repeat all that stuff we just did for everyone.
Every class, yep.
Self-development, dude. Listen.
Yep, it's self-development. It's optional.